Example number 2, little a is equal to 17.9 centimeters, little c is equal to 13.2 centimeters, and big C is equal to 75 degrees, 30 minutes. Okay, again, I just prefer to draw these. It does not matter who you call A, B, and C, so maybe I'll call this A, this B, this C. It does then mean that you've labeled little a, little b, little c. Right now we know little a to be 17.9 centimeters and little c to be 13.2 centimeters. And big C is 75 degrees, 30 minutes. Okay, so we are finding all the missing parts of triangle ABC. So we're looking for big A, big B, and little b. Side note, you cannot use Pythagorean theorem when you are not dealing with a right triangle. That is a common mistake on these problems. So, in order to do the problem, based on what we're given, we know big C, oops, I hate it when I do that. Big C and little c, which means that I'm definitely going to be using my sine of big C over little c. And that is equal to, I either need to make it equal to sine of big B over little b or sine of big A over little a. And which of those two do I have to pick? I have to pick sine of big A over little a because you have to know 3 out of the 4 things when you set up your proportion. Because we don't know either big B or little b, that is why we cannot use those for our fraction thing. I do think one thing I forgot to say when I first wrote the law of sines, you'll only ever be using 2 of these at a time and setting up one proportion. You never use all 3 of them together. Okay, so based on what we know, sine of 75 degrees, 30 minutes over our 13.2 is going to equal sine of, we don't know yet, big A over our 17.9. And then we're going to, well actually we just need to make this say sine A equals. And to do that, I'm going to multiply both sides by 17.9. That will give us 17.9 sine of 75 degrees, 30 minutes, divided by 13.2. And that is going to equal my sine of big A, who takes in numbers and spits out angles. That is inverse sine. So big A is equal to sine inverse of our 17.9, sine of 75 degrees, 30 minutes, all over 13.2. And our big A is approximately so we need to type this in our calculator. Sine inverse of 17.9, sine of 75 degrees, 30 minutes, divided by 13.2. And you hit equals and it tells you domain error. And what that means is that this value here, why can't we take the sine inverse of it? It must be bigger than 1. Sine of an angle will not give us an output bigger than 1. When we get an error like this, it actually means that there is no solution to this triangle, and that the triangle that you were presented was actually an impossible triangle. So, one thing that you are expected to know about triangles in general is that the longest side should be opposite the largest angle. The medium side should be opposite the medium angle, and the shortest side should be opposite the smallest angle. And there must be something wrong with our little c being 13.2 centimeters and our little a being 17.9 centimeters, whereas our C is 75 degrees 30 minutes. And big A must not be able to be bigger than him in an actual triangle. And so it's for this reason that we actually have no solution here. And so that is the downfall of the law of sines. When you are given two sides and one angle, and that angle is opposite to one of your sides, so two sides and one angle, and that angle is opposite one of your sides, you will be using the law of sines.